For years, I've torn down all sorts of appliances, exercise equipment, and even industrial machines to recover useful parts. I want to share with you some of my tips and tricks for how I do that efficiently. And I'm going to answer the two most common questions I get about it because I have a lot of videos on this topic. The first one is, where do I keep all these parts? And the second one, how do I decide what to keep? To explain all that, I need to start upstairs. Let's get started. Okay, to kick this off, we need to talk about my number one most important rule for salvaging parts. This goes beyond all the tips and tricks I'm going to share with you, everything about storage. This concept is first. You ready? If you don't remember you have it, or you can't find it when you need it, just throw it away. That part is completely useless to you. In fact, it's worse because it's taking up space rent-free. If you don't remember it, you'll end up buying it again if you actually need it. And if you can't find it, it's also just as bad as not having it. Just throw it away. It's really that simple. Well, it sounds simple. It's harder than you think, but I'm going to tell you how I manage that here in just a minute. And that's why we're going to start right here in my electrical storage area. Okay, so I've decided to pull up a chair. And let's talk about how I decide what to keep first, because this is the most crucial decision. You're going to come across a lot of parts that seem useful, but are they really? Here's how I decide. It's basically three things. I rank each of these three parameters on a scale of 1 to 10. It just gives me a nice solid way of measuring things. If I get 10 on all three of these parameters, it's a definitely keep. If I get a 1 on all three of these parameters, I should definitely throw it in the trash or, return it to the trash if that's where I got it from. So the three parameters are: how easy is it to remove, how frequently will it be used, and what does it cost to replace it? Of course, all of these things are relative because we all value our time differently and our effort differently. So for ease of removal, this is, again, a relative scale, right? And depending upon your skills, some things that seem easy to one person will be difficult to others. But for me, I'd like to think of it as a combination of time and effort. If I'm going to spend an hour with the grinder trying to get this part out, it's going to have a pretty low score. If I got to desolder under a magnifying glass and try not to burn the parts around it, it's going to get a low score. If I can take my drill and its 4 screws and get it out without damaging it apart, that's going to be a pretty high score. It was fairly easy to remove. Frequency of use is next. If this is a part that I use in most or all of my projects, it's going to get a very high score. For me, that's something like wiring, electrical components, which is why we're starting here. Electric motors or stepper motors, things like that are components that I use in nearly every project. And so these things are going to score fairly high. Other examples would be large gauge wire or pulleys, gears. Again, these are all things I use quite a lot because most of my projects are very mechanical in nature. They usually move. However, if it's a part that I'm unlikely to use by this time next year, storing something for a whole year with very little chance of using it may mean that you shouldn't keep it. But you're not just considering frequency of use, you're considering these other parameters as well. And that leads me to the last parameter, which is the cost to replace. Now, under this category, I actually consider two things: cost and time, like lead time, and the actual cost in dollars. So if it's an expensive part, I need to wait 2 weeks to get this thing, or it's kind of hard to find, it's going to score higher on this scale of whether I should keep it or not. If it's something that I can just run out to the store and pick up the same day, or I can order it online very easily and have it shipped within a day or two, then it will score a little bit lower because it's very easy and very low cost to get this item again. Now, the time urgency may be a little bit higher for me because I'm usually in more of a hurry to get my project going once I know the parts that I need. But if you're more willing to wait, you may not score it as high on the lead time scale. Again, this is all relative to what you want and what you do with your projects. So here's a great example. I just disassembled this large treadmill and there's a huge PCB with all sorts of juicy components on the board. I don't need the PCB, but some of those parts soldered to the board are useful. I am never going to desolder parts from a PCB. I know many of you do this. I get emails about it all the time. It's just not worth the trouble for me on this scale. Why? Because it's tedious to remove these parts from a board. I'm not as good as some of you who solder parts all the time. So desoldering is a little bit more challenging for me. It's going to take more time. Frequency of use is very low. I rarely ever use these small discrete components like this very, very rarely. And they're also very inexpensive and easy to replace. So I get a very low score on all three. It's not worth the trouble to try and keep those parts. So if I don't need the fully assembled board for some other parts in the assembly, it gets thrown in the trash. However, an electric motor usually only has 3 or 4 bolts that's holding it down. Snip the wires, it's pretty easy to remove. It's kind of expensive to get, there's a long lead time, and I use electric motors or servo motors in every project. That score is very high on all of the parameters, and thus I usually keep electric motors. And I'm going to show you examples of that here in just a minute. Okay, there's one more parameter that's a little bit harder to measure, but I know it bugs some of you guys. And that's that feeling of, because I got this thing free, you know, somebody gave it to you on Facebook Marketplace, or you were going to throw it away anyway, that you should keep it because it inherently has some value more than what you paid for it, or the fact that you're saving it from the landfill. And that's entirely true. Every pound of material that I save is a pound of material that doesn't go into the landfill. But that's a little bit misleading because there is some cost to you, especially to your inventory and the amount of space that you have available. That's why I think it's really practical to consider if you would actually use this. Because if you won't, then you've just basically made a trash pile at your home. You haven't actually saved the planet by keeping this trash at your home. And if you never actually plan to use it, its true value is 0. One more option to consider is to sell it. If it really has value, you could post it online and sell it as a used part, but you don't have to keep it. We're already saving the planet by keeping this other stuff. So let's just keep the stuff that's actually useful. I really wanted to mention this early in the video because you don't have a chance of being successful at this if you don't manage your space well and organize it in such a way that you can find these parts when you need them. Once we've decided to keep something, we need a good place to store it. And that's why I wanted to show you how I store my electronics. Now, I've got a couple of areas like this for different types of things. I'm going to show you my electric motors and powertrain stuff here in just a minute. But this is just one example of how you can store components. But if you're more limited on space, you might want to try something like this. These are much smaller bins, obviously, that go all the way back to my original ultra tiny shed that I started this channel on. You should go back and look at some of those videos. Wow, very little space. So I've since moved to a new house with a garage, and so I have more space. But the bottom line is I have these labeled bins, which I still use very frequently. And I also have these two, which I don't really use as much anymore, but I wanted you to see them for smaller storage options. These bins have these neat compartments inside, especially good for storing very small things like small electronics. Similarly, a slightly bigger version where I've got most of my stuff related to soldering and small electronics. Very small switches is the kind of stuff that's in here. But this is stuff I use very rarely. And there should be some more soldering stuff, soldering and circuits related stuff in here. And that's what we have. Also over here, we have another example of assorted bins. These are all fasteners. And I just keep a ready supply of the most common size fasteners that I use, both in metric and US customary. That's what you see here. The reason I use so many of these bins is because being organized is absolutely essential if you have any hope of ever finding these parts again. And so I really like having the clear bins like this that are labeled, or the open bins like what I have upstairs. So let's go back to that. I use a lot of these terminal blocks, so you see many of those. You'll also notice that some of the bins have a label and some of them don't. If it's way down low and I can very easily see what's inside of it, I don't bother to label it. But if it's up high like this and I can't see what's inside, I will tape a representative sample on the outside. And if you look inside, that's what you're gonna find in there. There won't be anything else mixed in the bottom. This is not a junk drawer. This is a terminal block drawer. And in this case, only this one type. But let's say switches, here we go. Here, I actually have several different types of switches, but there's a representative sample, a switch on the front, but inside you can find a drum switch. You can see many of these are old and used from industrial equipment that I've torn down over the years, but that one's pretty nasty looking, but it still works. But you get the idea. You want to make it easy to find. That's by far the most important thing. Don't create 100 junk drawers by mixing all the parts, because if you can't find it, you won't ever be able to use it. So tape you an example, and you have to be disciplined enough to not mix things, okay? Related to that, like this bin is pretty full, and you can see there's a mix of new and used components in here, but I can't get any more small motor controllers into this box. So this is it. If I'm going to keep any more, I can create another bin, but I've only got limited space. I can throw one of these away and replace it with what I find, or you can sell it online. You don't have to trash it. But the most important thing is you have to be disciplined controlling your space. Don't just keep shoving new things in there, because you're really just hoarding at that point. You're not actually making it so that these parts are useful to you. That's the key. You can also see I've got a whole bunch of these contactors. This is something that I use in a lot of my projects. And these, again, also came out of industrial equipment. I've got quite a few, but this bin is pretty full, so I won't be keeping any more of those. But you get the idea. That leads me to another concept, which is once a year, I will look over my whole inventory and decide if there's something in there that probably doesn't need to stay anymore. Having a yearly cleanup is a lot better than your space always being full and you're always trying to make a decision of, what do I want to keep and what do I want to throw away? If you prune your space every once in a while, it's very easy to, have a new item come in and go, oh, run it through your test, very low probability of actually using it. It doesn't matter if you have space, throw it away, don't keep it. Or very high probability of using it, it gets stored. So there you go. Let's go take a look at the motors. And back here, we have all of our electric motor and powertrain related stuff. So this is where I keep my wire, even purchased wire. Not all of this stuff is salvaged. But for example, this comes out of an old washing machine that I drug off the side of the road. It's a 1/2 horsepower. That's like 370-ish watts. Several AC and DC motors. The DC motors are usually over here. You can ignore that guy. He's from Jarvis punching days. So some of these motors come out of treadmills. These two in particular. This one also comes out of a treadmill, a large commercial treadmill. And that's a brushless DC motor, but you get the idea. This little bin has small, very small electric motors that I want to keep, mostly DC motors. So if I'm looking for that kind of thing, this is where I will go look first. I know it's very likely going to be in there if I have it, although there are a few scattered ones out here as well. These are servo motor controllers. Inside this bin here, we have more motor controllers. 2 of them come from treadmills. There's a few other ones in there, but yeah. So again, motor controllers or powertrain or motors themselves, that's the kind of stuff that will be stored back here. It's not quite as organized as what we just looked at, but you will also notice it's not crammed either. It's very easy to just scan this and find what you want. You don't want to just shove things in there, and it's especially important, if at all possible, to never put something on top of something else. I try to be very careful about doing that. You're certainly allowed to stack things, but if it starts to obscure what's behind it, you need to seriously reconsider whether you want to store it there or whether you should be storing it at all. All right, that's enough talking about storage. Let's get to the fun part, tearing things apart. I'm going to assume that you've got some basic tools, things like wrenches, a hammer, screwdrivers, but there are a few specific things that I want to point out, and that's what I got here to make sure that you've got the right tools for the job. In this case, a really strong pair of scissors is really important, not just like paper cutting scissors, but something approaching shears, something that would help you cut thin sheet metal. This is like a telescoping magnet deal, which I really love because something that you will run into over and over again is dropping fasteners and small things down inside of a machine. And then you need to, you need to be able to get it out. And that's what this is for. This thing has saved me so much trouble trying to squeeze my arm down into some tight space to pick something out. And then I just telescope this thing in, stick it down in there, and you got it. While we're talking about magnet stuff, you're gonna want one of these little flashlights, not necessarily this one, but what's good about this one is it has a magnet on the bottom of it. So you can, again, stick this inside of a machine, point the light exactly where you want it, and help you see in those tight, dark crevices that you're going to be digging into all the time. Safety glasses is one of those things that's really easy to forget, but protect your vision. You only get one pair of eyes. Another thing that's really helpful is a set of these safety bits for removing these specialty screws and things like that. You're going to be removing a lot of screws. At first, I bought a set like this, which has just a huge assortment of safety bits. And you'll see these things like that, which hopefully you can see that. It's got a hole in the center, and the fastener will have a corresponding protrusion that makes it difficult to put a regular bit in there. You're going to have to use one of these safety bits. The problem is if you just have these, and then let's say you get one of these extensions and you put that on there, the hole that you put this in to get the screw out won't allow you to put this whole thing down in the hole, and you still can't get to the screw. Now, of course, that doesn't keep me out. I'll just use a grinder or something like that. But if you want a more elegant solution, something where you don't have to cut up all the plastic and waste some extra time getting into this cabinet or whatever it is, you get one of these. And as you can see, that also has the hole in the center. These extended length safety bits have been huge for allowing me to get into any sort of appliance or device that, may be protected by these safety screws. But of course, if all else fails, a hammer or a grinder would definitely get you past tamper resistant fasteners. Of course, you don't just want the safety bits, you also want I think you call it a Robinson bit, the square end, the star end, like all the different types. You want to have a nice wide assortment so that whatever fastener you encounter, you can easily remove it. Next up, I have this set of vice grips here. And what I like about these is the nice pointy nose for getting down into really tight spaces. I actually have one that's about twice as long as this that looks like this. It's the same thing. If you want to reach down into a really tight space, I have found these to be really helpful. And I have the regular vice grips as well. So, of course, you want to have a full assortment of tools, but these are some really specific ones that I think will be especially helpful. Oh, I almost forgot. You should also get a heat gun. A heat gun is really useful for removing stickers, because often screws will be covered up by a sticker so that you can't see where all the fasteners are. And if you heat up that sticker, you can usually peel it off and then access the screw that's underneath. If you want, you can just take a screwdriver and just start poking the stickers, if you will, and see if it punches through. But the heat gun is a little bit neater. Peel it off, and then you can see all the fasteners or access holes for the fastener underneath. Okay, so we have our tools ready. You've drugged the old washing machine into the workshop. What do you do next? Basically, what I do is I throw on safety glasses and gloves. For safety, obviously. The gloves in particular are important because you're going to be handling sheet metal, and it's very easy to cut your fingers and give yourself a pretty uncomfortable day when you're bending and handling sheet metal, the body of the washing machine. So be sure you've got some gloves ready for that. The only other safety thing would be to unplug the thing. That's pretty important. Washing machines do usually have a capacitor, especially here in the United States, because we use induction motors. Some other countries, they use universal motors. But if there's a capacitor, you can start by just cutting the wires to it, and then you're good to go. If you have little resistors, you can bleed off that energy by just bending the tabs, touching it to the two terminals on the capacitor, and that will bleed off the energy that's in there. Don't have a resistor, you could be a little more brave and use a screwdriver, touch it to the two terminals. You'll get a little spark, especially if it still has some energy in it. And then the risk is gone. You're good to go. But also just simply cutting the wires and getting rid of the capacitor will remove the energy from, the machine, and then you're safe to work on it. After that, basically I start taking out screws and sorting things into a keep pile and a discard pile, with the exception of looking for the wiring diagram, because that's going to tell you how to wire the motor. And if there's anything else that you want to reuse, you're going to want that wiring diagram to show you how things were wired before you start cutting things and taking things apart. For the washing machine, that's usually in the top cabinet section where all of the knobs are. Right behind there is where you will usually find a piece of paper shoved in there, and that'll be the wiring diagram. You definitely want to keep that. But even if you don't have the wiring diagram, or you don't know how to read a wiring diagram, that doesn't matter either, because I made a whole series of videos to teach you how to take pretty much any motor, figure out what kind of motor it is, and how to wire it. There's just too much to put into this video, so I will put links to those videos in the description. But if you have a motor from a machine, I can help you figure out how to make it run outside of the machine. Just check for those videos in the description. Related to that, there's some tools that are very specific to the type of work that you're going to be doing. So if you're tearing down computer parts or working mostly with electronics, then you're going to want a good multimeter. You're going to want things that are specialized to desoldering. Like I've got this tool that I use to help suck up the solder from a part after you make it molten. You use this to draw the solder up off of the part. So this is another tool that I don't think is essential unless you're working specifically with soldering related stuff. Speaking of electronics, you might even want something like an oscilloscope if you're really serious. So the list of tools, tips, and tricks can be pretty extensive. So I thought rather than try to list all of that in one video, what if we crowdsource it and add that stuff to the comments? I've got many of you who are really interested in microelectronics, or you're interested in computers, or you're specifically interested in getting the steel so that you can weld other parts, and you might not be interested in electronics at all. So you're going to have your own tips and tricks and special tools. I would love to read about that stuff down in the comments. Not only will you guys get my tips and tricks, but we can all learn from each other by reading through the comments, and this video will continue to get new life as more and more people come along and we crowdsource those great ideas. So scroll down and add your thoughts. I'd love to hear from you. Just because you don't want to use something doesn't mean it's completely invaluable. For example, you don't need to throw away the sheet metal. You could take it to one of those scrap metal places if you have one locally. They'll usually give you a little bit of cash for the metal. And that includes the motors and stuff like that too. Any of the heavy metal parts, the steel frame, the motor itself, all of that stuff could be traded in at a scrap metal place if you don't want to use those parts. When tearing down treadmills, there are these long beams along the edge, and that's usually square tubing that's quite strong and very useful if you do any welding and you want to use those components. Keep in mind that those square tubings are in there. You may want to cut the ends off if they've got special brackets on the end. And then you've got some raw material square tubing that you can use in a future project. I've also taken apart large commercial printers, and they often have the ink is like a dry powder. You're going to get it all over your hands and all over your clothes, and it's going to be in the air. So when I take those kinds of things apart, I will do that outside. And it's also good to wear a respirator and cover your face to just make sure that you're not inhaling that powder that's coming out of the machine when you start to take it apart. Other than that, I think that pretty much covers it. You just got to put the work into getting all the parts out that you want. Now is a good time to answer some questions that I'm pretty sure will come up in the comments. The first one being, where do you find these machines at to get started if you're not throwing away something yourself? And the answer is there are quite a lot of places. In fact, I made a whole video about this called How to Get Almost Any Part for Free, something to that effect. So I'm gonna put a link to that video right here and down in the description. But that video is a really good complement to this one. It kind of fills in all the gaps around where do you look for these things, how do you get started, stuff like that. Speaking of videos that complement this one, there's another video that should be coming out very soon, hopefully the next video, where I tear down this robot arm to reverse engineer it and learn from the professionals who designed this robot arm. In that video, I'm going to focus much more on what you can learn from pre-existing designs to implement in your own designs or just to improve your own engineering skills. And those ideas come straight out of this book. This is a textbook that I helped write, which we're releasing this year. You can see it says Contributions by Jeremy, maybe you can see that. And these two amazing engineers who wrote most of this book, I just helped review and contribute a few sections. But one of the sections I contributed is the section on reverse engineering. In my opinion, it's a fantastic book for teaching young engineers how the best engineers in the world design products for real. I also think it serves as a really powerful desk reference for any engineer who wants to quickly narrow in on the right problem using the best practices available and design good products. So if you want to learn more about this book, get yourself a copy or even just look at the individual chapters. You could order one chapter at a time if you like. All that information is available on the website. I'll put a link in the description for you. Another question I know I'm likely to get is, what do you make with all of this stuff? I've made everything from mechanical clocks to homemade power tools using salvaged components. I actually have so many projects related to salvaged parts. I've got dedicated videos to each machine. So there's a video called Things You Can Make with Washing Machine Parts, Things You Can Make with treadmill parts, and so on. So I'm going to actually list all of these videos down in the description because it's way too much information for one video. And I even have videos like how to wire a motor and how to use relays and all of the other auxiliary information that you need in order to be able to make these projects come to life. And that's really the goal of my videos, is to show you how to bring your projects to life. So I hope you'll check out those resources and get to building stuff.